Good afternoon, everyone. I'm Pete Bigelow, technology and mobility editor from Car and Driver magazine. And joining me today is Austin Russell, founder and CEO of Luminar, one of the leading LiDAR companies in the automotive space right now. And thank you all for joining us this afternoon. Austin, why don't we get the ball rolling by just kind of, for those who don't know, how exactly does LiDAR work and what differentiates it in terms of what does it provide that radar and cameras don't for those who need a quick primer here?
Yep. Yeah, absolutely. So LiDAR stands for light detection and ranging. And really it's kind of emerged as the critical sensor to help autonomous vehicles see and understand everything in the world around them reliably. So what it really helps these cars do is help go beyond just identifying if there's something out there, but better recognize where it is, what it is, and how it's moving in 3D space. And it's really emerged as something that's critical to be able to get to autonomous cars to the point of where they can have many nines worth of reliability. If you want to be able to have an assisted driving system that can operate in very constrained conditions and requires constant human oversight to be able to operate and correction, then that's good. But you really do need a very high performance LiDAR if you want to be able to accurately navigate reliably in an autonomous mode.
Yeah, Elon Musk says that you don't need LiDAR for autonomous vehicles. But I would suggest that perhaps the market right now suggests otherwise, as we're awash in dozens of LiDAR startups these days, as I'm sure you're tracking and know all too well. What differentiates Luminar's technology from the masses right now?
Yeah. So I guess like you're saying, it's LiDAR is critical for going beyond that assisted driving mode if you want to be able to get a driver out of the loop in that sense and not require constant human takeovers. But for this and for us, the big differentiator for what we built is that we really spent the past 5 years or really up until just coming out of stealth mode just around 1 year ago, developing really the core technology behind this, working completely from the ground up, building our own lasers, receivers, scanning mechanisms, processing electronics, rather than just using off-the-shelf components and integrating them together. And really, what this has allowed us to do is to be able to have a system that can see orders of magnitude better resolution and about 10 times farther for dark, hard to see objects for LiDAR systems. And like I said, it's all about going from a system that can see some things some of the time to all things all the time, which is what autonomous cars are really absolutely need if we want to be able to go from cool demos of systems to real world deployable and scalable cars.
You mentioned something earlier that we would agree you definitely need LiDAR for level 4 automated vehicles and above. How about that level 3 where there is a human involved? I know Audi, for one example, has LiDAR forward-facing on their level 3 Audi A8 sedan. So is there a role for LiDAR in even level 3 vehicles?
Yeah, I think it largely in part depends on how you define different levels, in here, sometimes we kind of joke that there's a lot of level inflation, within the industry as a whole. But, for level 3, by the strict definition, it's actually supposed to be driver out of the loop, but constrained to, certain scenarios, like, for example, freeways, where, you could have an exit-to-exit autonomous functionality where you don't have to have the driver constantly paying attention, ready to take over, but, once you get off the off-ramp, then it basically, it gives you a 2-minute heads up and there's, a handover with that. So, the big differentiator, I think, is if you want to go from something that, follows a couple of lanes on a road, and can, guide the driver to something that's being truly autonomous and having a driver out of the loop mode, in any given scenario. That's when LiDAR is really, really required. And, you look at, you mentioned the, Audi A8 system, which, you could, I mean, don't get me wrong, they're really cool products, but you have to take into account that they all can only operate in very constrained conditions. Let's say, on certain lanes and certain freeways and going less than 37 miles per hour when it's tracking a car in front of you, and you still have to be ready to take over ultimately. So, if you define autonomy that way, then sure, you still do need a LiDAR, but not something as high performance. But if you want to get the driver out of the loop in these types of scenarios at high speed, that's something that requires a completely different level of system.
Okay. You mentioned 5 years in stealth. Luminar's been around for 6 years, which puts you as one of the veterans of the LiDAR industry and what we all perceive as a very young field. As you were building that technology from the ground up, you mentioned you build your own receivers and have a very kind of unique approach to that. Can you elaborate on what that is a little bit?
Yeah, absolutely. So, really, rather than using a standard wavelength of light, which is 905 nanometers, which is what's traditionally been used in the LiDAR space, we actually picked a different wavelength for this. It's a 1550 nanometer wavelength. That's something that's actually allowed us to be able to output orders of magnitude more laser power while still staying eye safe. Eye safety is actually one of the big limitations of LiDAR systems in the sense that if you try to output more power so they can see a lot farther, then it would start damaging people's eyes, in the current configuration. So not a solution there. And given that even some of the best performing systems today, you see like the big spinning buckets on roofs of vehicles, for dark objects at freeway speeds, you can only see them around like a second ahead, not very long at all and not nearly enough. We need just completely different level of performance from a range standpoint and also resolution at range. So in order to do that, you need to change the wavelength of light. Unfortunately, though, that means that you can't use just standard off-the-shelf silicon photodetectors with this. You have to use a new special material called indium gallium arsenide. And with that is we had to be able to find a way to be able to fabricate a photo receiver to see the light back at this 1550 nanometer wavelength with this indium gallium arsenide photoreceiver and build our own ASICs and chips to pair with that. So this was a arduous journey and process that required a lot of work at the system level and engineering level, and also even an acquisition along the way of what's now a 30-person team in Colorado. For our ASIC design and chip design on that. So that's been one of the key components that's allowed us to see a lot farther and higher resolution.
So building your own LiDAR with all that engineering effort is obviously not cheap, and cost is one of the major drivers of the auto industry, or at least that seems to have been a storyline with LiDAR over the last year, 2 years in the industry, is that, well, we can start outfitting these cars with LiDAR once the cost comes down. But that's not your take on it. Your take is essentially that, sure, you could put together something cheap off the shelf, but that's not necessarily good enough for what we're really going to need to make this work. Yeah,
absolutely. And if you want to talk about just cheap, for example, from a LiDAR standpoint, you could go down to to Best Buy here and buy a $50 solid state LiDAR that sees out to 200 meters. It's a golf rangefinder that tells you how far away a flag is, But the reality is that's something that, while it sounds really good in theory, is like completely not applicable to autonomous vehicles. And I think that's really the challenge with these systems, is that while we've seen a new trend to be able to reduce the cost of these devices, we've actually seen the performance proportionately be reduced along with the cost, which actually doesn't really get us anywhere. The whole point is we needed orders of magnitude better performance from the start if we want to be able to get from these autonomous test fleets from where we're at now that need constant human oversight and takeovers to being able to get something that is truly autonomous. At the same time, though, obviously it does ultimately need to be cost effective. And that's why we did an announcement just a couple of weeks ago here about how we've been able to make this receiver system in our LiDAR that a lot of people traditionally assume would be very expensive, really cheap, or we made it really cheap and only use one laser and one receiver in the product, as opposed to what would traditionally require like 64 lasers and 64 receivers. So gotten the cost and complexity down dramatically, which is critical long term. Ultimately the cost near term isn't as big of a deal as for autonomous tests and development fleets, but it's important that things scale long term from that standpoint. But also, you can't sacrifice the performance to be able to get there. You have to do both.
And obviously, your approach has garnered a lot of interest in the auto industry. I know you're working with some OEMs that you cannot disclose with us today, but you are working with Toyota, and that's when you can a relationship you can talk about. What is the status of your work with them, and what have you learned with them so far?
Yeah, so we've had a really great feedback loop from our OEM customers and partners. This is something that we go pretty deep on these. We specifically picked 4 OEM partners off the bat to be able to work with, and that's really what 2017 was about. It was being able to have demonstrate the technology really coming together in these initial systems and getting it deployed to OEM partners, and have something where these are not just like one-off sensor sales. This is something where their fleets are committed to this, and they're committed to this type of technology for autonomous developments going forward with these partnerships. So it's been a great tight-knit relationship, and has allowed us to be able to continuously improve our product as we move towards, like I said, these low volume production systems to higher volume systems for larger test fleets, and 2 in the coming couple of years here, series production, volume products for consumer vehicles. And it's something that requires a lot of in-depth work and a tight-knit relationship with the end automaker and customer to be able to cleanly integrate that volume production product for consumer vehicles. So it's been good.
All right, let's talk about that production aspect a little bit, because of all those LiDAR startups that we mentioned earlier, there's very few companies that are actually mass producing LiDAR units at this point. Luminar is one. You have a facility in Orlando. How many units are you capable of producing, and how is that changing this year, and how are automakers ramping up those plans?
Yeah. So we're currently ramping up our capacity by nearly a factor of 100 here over the course of the next 12 months, where we're looking at going from, like I said, equipping these low volume test fleets to being able to help our customers scale up to get the volumes of vehicles they need to get things validated to ultimately put it out on the road at scale in consumer vehicles. And aiming for that, proverbial, kind of 2021, 2022 timeline for these initial, vehicles for consumers, from a customer standpoint. So, but that being said, we're starting out where we're ramping up production capacity. We're looking at by the end of this year, we'll have a capacity north of 5,000 units a quarter, which is something that is critical that you get out to automakers at scale now effectively, because you think about the types of design cycles that they have. Normally automakers would have like a 7-year design cycle where something going into like a 2021 or 2022 car would have to have been designed in years ago. But this is something where automakers are really pushing the timelines for what's possible there in order to be able to try to get these things out as quickly as possible, but need a product that can actually scale to those volumes. So starting with this, kind of mid volumes for autonomous test and development fleets, and having the first sensor that finally meets those key performance requirements, but also something that you can actually build effectively, where we can assemble each unit in as little as 8 minutes, which is a big jump from the days or weeks that it takes to build current LiDAR sensors. So that's how we can scale to those types of volumes.
Talk about a little bit in terms of the units that you're starting to produce. What is the range that LiDAR can sense right now? How far down the road? What's the possibilities? What are the limitations? Yeah.
So there's definitely some major challenges from a performance standpoint, for existing systems, in the sense that it's very easy to be able to see very select conditions, like let's say perfectly bright white reflective objects at distance, and in theory there's a lot of LiDAR systems that can see like a couple hundred meters for a perfectly bright white reflective object that your laser happens to land on at distance. But just because that's the case, it doesn't mean that when you deploy it, it's going to be safe in an autonomous system. Is that you have to be able to see all types of objects, including dark objects, which are notoriously difficult to be able to see, and also be able to have enough resolution on those objects and enough points to make out not just if there's something, but what it is. And that's with current systems, you can only be able to accurately make out these dark objects. For even some of the best commercially deployed ones today at like, call it, 30-ish meters or so. Where, like I said, at freeway speeds, that's literally, a second ahead, and that's why we had to design something that can see out, these dark objects way out to 250 meters, and be able to have enough resolution on it, with basically a, up to 50x increase there, compared to some of the most widely deployed systems today, that so that you can be able to clearly make it out every time. See those difficult edge cases, when a kid runs out into the street chasing after a ball, when there's a tire on the road up a distance that you need to avoid, or dead stop traffic. So those are the things that we can finally solve for.
That's probably a great lead-in for a question about the Uber crash that I think many people saw in the news at the very least over the last month or so, with the caveats that your LiDAR were not on board that vehicle and you don't work with Uber, and I know the NTSB is still investigating that. What more generally, what should LiDAR have sensed in that particular scenario, and and what do you learn from that? What still has to happen?
Yeah, so I think that incident has really caused a lot of autonomous vehicle programs to kind of take a step back and reevaluate how they think about one, long-term vehicle deployment plans, but two, also even just like a near-term autonomous vehicle testing plans. What is really safe, and not. And I think of course the LiDAR is at the center of that, where that's like a proverbial case where a LiDAR is supposed to be able to solve that problem, of like seeing something at night up ahead, that's crossing the street. But yeah, there's it goes to show that there is a whole software component of it. Where just because a LiDAR theoretically could get a couple of points on an object doesn't mean that it can be accurately recognized every time. And that's why you have to be able to take into account a full stack perspective about making sure that LiDAR is good enough where it can be able to effectively recognize those objects every time, not most of the time. So and that requires a completely different level of performance and the right software to be able to process it ultimately. Yeah. Maybe
bigger picture from the technology itself. Do you feel that accident in particular, or more broadly the idea of safety in autonomous vehicles, does this hurt consumer acceptance?
I think maybe while I think it's actually been in some weird way for a lot of programs, it's been good that people are taking a fresh look and approach from the safety perspective. Where I think in some cases it's rolled back plans a little bit, but in other ones it's firmed up some companies' thoughts and opinions that it does need to have it needs to be truly safe before you can actually deploy this stuff at scale. And the reality is that there's still a long way to go, for these autonomous vehicles to be truly out on the road and safe in all these different types of conditions. But I still think that from a consumer vehicle standpoint, we'll still see these out on the road. Even for example with our sensors as soon as 2021, 2022. So those long-term plans are still on track, but near term, it's like I said, the industry's certainly taken a healthy look at the way things are going.
Okay, so final word as we get close to our time here. Your takeaway essentially is that we need to cut through the hype and take a more realistic view of where we're at on the timeline to autonomy.
Absolutely, yeah. Like I said, there's still a long ways to go from, sometimes, companies will make it seem like, fully autonomous vehicles that drive, everywhere are just around the corner. But the reality is that even with these best performing sensors that can finally be able to enable vehicles to operate safely, which, are not on these autonomous cars today, there's still an incredible amount of work left to do to be able to get to that point. And that's why, I think starting in that, 2021, 2022 timeframe, we're going to see autonomous vehicles operating in much more constrained conditions, like starting out with freeways only, for example, and then expanding from there versus, the proverbial like urban ride-sharing type applications immediately.
Great. Austin, thank you so much for your time today. Thank you all for joining us this afternoon. Appreciate it.